Hi, today we're going to talk about oscillations, which are oscillations that include force of friction, which is the force that opposes to the movement. And we know that it's a vector that is expressed like this. We only use this term, the second term, if the velocity is huge. So usually it cancels out and we are only left with this term that can be rearranged as minus v times the velocity. And we know that v is a damp constant. So if we, for example, have a string attached to a mass, we know that the forces of the spring is going this way and is expressed by minus k times x. So the force of friction opposes to that movement and goes this way and is expressed as minus v times the velocity. So if we use Newton's second law, we know that the sum of all the forces must be the mass times the acceleration, right? So we put the forces and we rearrange to 0 and divide over m, so we can get the acceleration plus k times m times x plus v over m times the velocity, that equals to 0. And this term we know it's omega, and in this case it's omega initial, and this term is called gamma. So the equation is and this is the equation that describes how a damp oscillation moves. But if we solve it, we get the equation of the position in function of time. That is almost the same as in simple harmonic motion, but we have to add an exponential term. And we have to use omega prime because, as we know, we're adding force of friction and the wave is decreasing. Times t plus 5. And this is the equation of position in function of time. Also, we have to have another equation that relates omega initial and omega prime, and that equation is omega prime equals the square root of omega initial squared minus gamma squared over 4. And these are the equations that we are going to use to solve problems. Let's solve a quick problem. We have a vertical spring attached to a mass, 10.6 kilograms, and it has a K of 2.05. And we also know that the damp constant is 3. So they're asking us to get the frequency prime. So we have all the data to get omega prime. Well, omega initial, that's the square root of k over m, and that gives us a result of 43. And with this and the equation that I explained before, I can get omega prime. And this can be rearranged as if I plug in the data, I get that omega prime is and having omega prime, I can get f prime, knowing that omega prime equals 2 pi times f prime, and f prime equals omega prime times 2y. And if we plug in the data, I get 7 Hertz. And that's a quick explanation of damn oscillations.